Warahmatullahi Taala Wabarakatuh. Good morning, class. Okay, so now kita continue with applications of Dalton's law. So far, teacher dah introduce to you guys what is the Dalton's law and also the equation related to Dalton's law. Sekarang ni kita belajar is application kepada Dalton's law, which is water displacement method ataupun dalam Malay kita panggil sebagai kaedah sesaran air. So it says here that in your module, page 202, so one of the applications of Dalton's law is to calculate the pressure of the gas collected over water. So this method is used to collect gas that do not react or insoluble in water. For example, oxygen gas, hydrogen gas, and also nitrogen gas. So if we take a look at the diagram provided to us, for example, inside this conical flask, so a chemical reaction occur between reactants. Kalau kita campur reactants together inside the conical flask, so the chemical reactions will occur, and one of the product adalah gas, right? So the gas that is produced by the chemical reactions, they akan flow through the tube, and then they akan since the gas is not react ataupun insoluble in water, so dia just akan pop out and then dia akan being collected dalam chamber ni, and here selain daripada gas collected through the chemical reactions, so if you perasan dekat sini, disebabkan ini adalah water, so on the surface of the water ni akan sentiasa berlaku proses vaporization, means berlaku proses penyejatan. So that's why inside this chamber bukan only ada gas yang terhasil from the water displacement method, but also akan ada presence of wap air, water vapor. So water vapor ni dia akan coming from the vaporization process yang berlaku pada water surface ni. So that's why inside the chamber right now kita ada mixture of two gas. So kita ada gas collected over water ni and also water vapor. So teacher ajar, kalau ada mixture of gas je, kita akan automatic kira total pressure based on Dalton's law. So that's why dekat sini it says that the total pressure inside the chamber right now is equals to partial pressure of the gas collected plus partial pressure of water vapor. So dekat sini kita akan apply Dalton's law. This is the Dalton's law that you have learned in the previous class. So according to the next tips here, it says that the total pressure, PT, not only come from the particular gas collected from the chemical reaction, but also from the water vapor. To further understand this method, jom kita try example 8. So in the example 8, so oxygen gas, so right now, the chemical reaction inside the conical flask produce oxygen gas. So the oxygen gas produced by the decomposition of potassium chlorate. So decomposition of potassium chlorate, KClO3, eventually dia akan produce oxygen gas. So the oxygen gas ni, dia akan flow through the tube and then dia akan collected inside the chamber through process of collecting gas over water ni lah. Collected over water. So bila awak jumpa istilah collected over water, maksudnya dia refer kepada water displacement method. Ini clue dia. Ini statement collected over water, dia refer kepada teknik water displacement method. Alright. So what are the informations given in the example? So it says that the volume of the gas collected at temperature 26 degrees Celsius. So you have the temperature, and atmospheric pressure of 765 mmHg. So this is your total pressure. Macam mana kita tahu 765 mmHg ni adalah total pressure? Because for your information, kalau dia nyatakan nilai atmospheric pressure 765 mmHg, so dia sebenarnya refer kepada total pressure of the mixture of the gas inside the chamber. Okay, inside here. Right, so this is your actually total pressure. Okay, is 175 ml. So this is actually the volume. Okay, this is the volume of oxygen gas collected over water. So the question is, calculate the mass in grams of the oxygen gas obtained. And also, you have another information, given pressure of water vapor is 25.21 millimeter mercury. So this is the partial pressure of water, pH2O. So we want to calculate the mass of oxygen gas obtained inside the chamber. Okay, so what do we need to do is, before kita kira mass of oxygen gas obtained, kita kena kira dulu, calculate what is the partial pressure of the oxygen gas collected. Okay, so teacher label ini sebagai step 1. So in order untuk calculate the partial pressure of oxygen gas collected dekat chamber ni, so kita akan apply Dalton's law, because we know that ada mixture between oxygen gas and also water vapor, H2O. So using this Dalton's law, so kita nak cari partial pressure of oxygen gas. So PO2 is equals to P total minus PH2O. So 765 mmHg, which is the P total, minus the partial pressure of water vapor given 25.21 mmHg. So you will get 739.79 mmHg. Okay, alright. Next, you dah ada partial pressure of oxygen gas. Okay, sekarang ni, the next step is you guys nak cari mass of oxygen gas. So what do we need to do adalah, untuk cari mass of oxygen gas, kita kena cari dulu number of mole. Okay, kena cari dulu number of mole of oxygen gas. So sekarang kita akan guna step number 2. You have to use ideal gas equation. PV equals to nRT. So inside this ideal gas equation, kita nak cari number of mole of oxygen gas dulu, N. So that's why kita rearrange this equation, kita nak cari number of mole of oxygen gas. So NO2 equals to P. So pressure ni adalah partial pressure of oxygen gas. So PO2 V over RT. Cumanya apa yang teacher nak korang betulkan adalah nilai R, gas constant, yang teacher kata untuk syllabus kita adalah 0.08206 liter ATM per mole per Kelvin, right? Okay. Cuma bila awak perhatikan dalam solution ni, soalan diguna nilai R yang berbeza. Sebab teacher kata kita ada a lot of R value, remember? Cumanya untuk level metric, teacher nak awak guna 0.08206 ni. So yang ni awak cancel out. Okay, cancel out. So teacher nak you guys convert dulu pressure ni kepada ATM. Sebab kalau unit R constant, kita pressure dalam ATM. So convert kepada ATM. Yang ini you guys akan dapat, so 765. So 739.79 mmHg. Convert kepada ATM. Okay, sila convert kepada ATM. So dapatkan ini dalam unit ATM. Okay, so yang ini pun make sure dalam unit ATM. Dan yang ini awak guna this one. Okay, 0.08206 liter ATM per mole per Kelvin. So temperature ni pun dia dah convert kepada Kelvin. So volume pun dia dah tukar kepada liter. Sebab asalnya dia bagi volume in milliliter. So you will get, even though you use a different value of R, don't worry, because you will get the same value of number of mole. Kalau ada beza pun beza sedikit sahaja. However, you will still get the same answer, which is the mass of oxygen gas adalah 0.22 gram. Okay, so remember to convert the pressure in ATM. Right, so kalau boleh faham example 8, okay, you guys continue with, okay, practice question 10. So practice question 10, okay, by using water displacement method. Okay, so 128 ml of oxygen gas. So this one also produce oxygen gas. 128 ml is the volume of oxygen gas. was collected from the decomposition of potassium chlorate, okay, at 24 degrees Celsius. This is the temperature. And atmospheric pressure of 762 mm Hg. So this is the temperature and this is the total pressure. Okay, so calculate the mass of oxygen gas obtained and given the partial pressure or the vapor pressure of water at 24 degrees Celsius is 24 mm Hg. So this is the partial pressure of H2O. So final answer is given to you. Okay, if you have any question, boleh terus tanya teacher. Okay, class, thank you so much.